Okay, as we proceed today, if you're looking at this, and we're laughing with people, we're not laughing at them. Maybe you are, maybe in your mind. What does it mean when we say, well, you're just going through some growing pains? What does that mean, do you think?
Everyone goes through it.
Yeah, everyone is probably going to have to go through it. This is not unique to this class. It's not unique to your learning level. The reason that this is so difficult is for two things. One, you really haven't been taught a whole lot of this yet, and two, it's brand new. So which I understand we would say one feeds into the other, and there's no indication of anyone saying I don't like this, I hate this, I'll never understand this, and maybe all the above is true, but the applications for this are probably, well, I'll say it's one of the things that you just don't think of. And the reason I say that is when we walk outside and it's perhaps a really hot day where we think it's getting close to triple digits. Yes, that's true, but again, that's just the average amount of heat. Because when you apply heat given off to an engine or a motor, okay, not only ain't going to be that hot, but could be a lot hotter for various reasons, okay? One of the best ways to cool an engine off is while you're driving, because two things are going to happen to your engine as you're driving down the road. Can you be more specific? You're not wrong, okay? So as you're flowing, yeah, maybe you're flowing. So as you're driving down the road, you're going to have air flowing underneath. If it's a supercharger, you're going to have air coming in. I'm just waiting for us to cut a hole in the hood and drop a supercharger into it.
You mean like
I'm not looking at you. I'm not looking at him. I'm looking in the back row.
Well, that's surprising if he did it.
Because do you have a Dodge? What type of car is it?
Charger.
Okay, so it's a Pontiac. Okay.
Not so pretty good car.
So yeah, it's still a pretty good car. I mean, Burt Reynolds drove one. Probably the most valuable car, well, one of the most valuable cars in history, because he was in, of course, Smokey and the Bandit. But so you're taking air in through your supercharger, air's flowing around it. But more importantly, you have a fan blades, so and your radiator will circle that around. So it's just a lot of things that happen. You feel heat coming out of the hood, or on the hood, and that's actually quite hot. But the closer you get down towards that block, you cannot put your hand on it because it's just way too hot. So you're measuring the average amount of heat around that. So my point is, we deal with this all the time, you just don't really realize it. So I think the best place to start would be probably just even, for instance, number one, so we can just get our feet underneath us, okay? Because every time that you read these problems, the very first thing we want you to realize as you're doing that, maybe the first two things is, one, is it a known or an unknown substance? And two, what is it asking for? Okay? Because if it's asking for heat, again, we know it has to be in joules or kilojoules. If it's asking for a molar mass, we know it has to be measured in grams per mole. If it's asking for a heat of fusion or vaporization, it's joules per gram or kilojoules per mole. Okay, so we'll get you pointed into the right direction. Okay, so water's molar heat of fusion is 6,000, or not 6,000, that'd be really high. 6.009 kilojoules per mole. Calculate the amount of energy in heat that you would be required to melt 7.9510 times 10 to the 5th grams of ice. Now, does it say anything about changing ice to steam?
No.
So therefore, since it doesn't say that, does that eliminate a 5-step problem? Yes, it does. Does it have a temperature range in it?
No.
No, it does not. So you're not trying to calculate the energy from a certain temperature range. You're just given two variables in there. So what are we trying to solve for? It's a known substance, and you said joules is right, or kilojoules, okay? And it's already in kilojoules per mole, so we will just solve for kilojoules. And again, as we're approaching these, again, if you're frustrated, that is not unique to this class. Again, it's what we'll call growing pains, going through this process of, per se, trying to learn this content, okay? So, what number do you think we would start with, the grams or the heat of fusion? The grams or the heat of fusion?
Someone take the other one.
Yeah, you probably about 80% of the time you have grams, you're probably going to start with that. And also, if you have something in grams, you're also probably going to convert that to what? Yeah, right. And is this a known or an unknown substance? Okay, so if we have, what would that be? 79,500 grams. Okay, taking that scientific notation and converting that to grams. Now, there's
795,000.
795,000. Okay, so you can just do this. So we wouldn't write grams of ice here. We'd rather write grams of what? Yeah, so it's water in a solid state because it's ice, okay? Or if you're not a scientific notation person, 795. So there's 2 decimal places. So we got to put 3 more. 795,000 grams of H2O, whichever way you want to look at it in your calculator. So we'll just go ahead and put it down here because, did anyone put it in the whole number, or are you using the scientific notation? Okay. So how do we get rid of this gram? Say that again.
18.02 grams.
Oh, I thought you said oh. You did, didn't you? Okay. I should probably stop doing that because it's just social convention. So many people do that. Okay. So now that's for every mole of water. Now I'll let you figure out how to get onto the home stretch. We've got that mole. Do we want to keep that or get rid of it? What's the question asking for, though? We want to get rid of it. And there's only one number left. So 6.009 kilojoules. That go up on top or the bottom?
Kilojoules.
Yeah. So you're going to put your kilojoules on top. And then what will go on the bottom? Yeah. It's for every mole. So those are all gone now. You're just left with kilojoules, and it's asking for that. How much heat? Okay? Number 2 is perhaps a little more tricky because it's given in 2 steps. Okay? Number 2, given that a substance has a molar mass of 259.0 grams per mole, and 71.8 grams of the substance absorbs 4.307 kilojoules when it melts. Calculate how many moles are present in the sample and the molar heat of fusion. Okay? So the end result, how is a heat of fusion measured? How is a heat of fusion measured?
And if you move the decimals about 3 places to the left, how far off am I?
Yeah, kilojoules per mole or joules per gram. Okay? So what you need to find first okay, is how many moles are present, okay? And I would make this 2 totally separate steps, okay? This is more so teaching you thinking skills more than anything else. Man, a lot of students crack their necks like that. It's got to feel better.
Did you see that?
No, I heard your neck
Oh,
crack.
not that. It felt nice though.
Okay, do I need to see that?
No, did you just, we looked at each other and
Oh, okay. So there in that problem, what number do you think you're going to start with?
the heat of fusion.
Why? Because it's in grams. About 80% of the time, you're probably going to start with the grams. Okay. It's a known or an unknown substance.
Unknown.
Yeah, we don't know what it is. Okay. So we've got 71.8 grams of this, and our end result is going to be this or this. Okay. So and it doesn't ask, it should say give the molar heat of fusion in kilojoules per mole, but I think you would presume that that's what you'd want to do because you're given 4.307 kilojoules. Okay, so how are we going to get rid of that gram in our next step? And that goes all the way back to last August and September. Okay, so and then it's at that time we said we want to split these up because once you divide this out, okay, that's going to give you what? Okay, and then I guess maybe if you wanted to extend, but to me it makes more sense this way. So if we have our moles on the bottom that we want, and how many kilojoules were absorbed?
Okay, wait. That would be the one answer, right?
Yes.
Okay. Cool. About half of it, right? 4.307.
Okay, so we got 4.307 kilojoules, and there was our number of moles, 0.28. Okay, and then once you divide these two numbers, you're given a value in kilojoules per mole, and that's what we're looking for.
So wait, you can divide them? We were thinking you couldn't because they had two different ends.
Oh, well, it's more so of a derived unit, but maybe if you wanted to, maybe it makes more sense to go along this route because you're still doing the same thing. I don't know, I've just always looked at it, kilojoules per mole. Or if you want to do this, I guess you can do that. They cancel each other out. And then we've got no, something's not right here. You do have to split them up. That's the only way you can get kilojoules per mole. Just get the one answer, divide that into there. Yep. Those are probably the 2 hardest problems on this paper.
1 and 2?
1 and 2. Not the shortest, or excuse me, not the longest, but probably the 2 hardest ones.
We were split on 4.
Okay? So then in number 4, okay, is this a known or an unknown substance?
Unknown.
Okay? And what is the question asking for with this unknown substance in number 4? Molar mass. And molar masses are measured in what? Close. Closer. You gave everything, but you just put the 2 together. Grams per mole. And maybe you said that and I just didn't hear you.
I did say that.
Okay?
Yeah, you were backwards. We just couldn't figure out which one.
Okay?
Oh, yeah.
So in this case, follow this same pattern. What number are we going to start with? So if we got 64.2 grams of this unknown substance, and what is the question ultimately asking for? The molar mass, correct? So do we want to keep this gram? Yeah, because it's measured in grams per mole. Okay? So in our next step, how do we get moles on the bottom? Yeah, we got kilojoules per mole, so what number goes on top? So if we put 3.43 kilojoules on top, this unknown substance has this molar heat of fusion of 3.43 kilojoules for every what? For every mole. Okay? Then what we see happening, okay, we've got our grams, we've got our moles, but we got to get rid of that kilojoule.
So by how? Multiply by
Divide by 2.77.
Why?
Because you gotta put the kilojoules at the bottom.
And so we can do what?
Get rid of that.
I see.
That's right. So now we've got, what was it, 2.77. Okay, this is just like doing an additive inverse. If you want something here, you can just put 1. So our kilojoules are gone, and we've got grams per mole. Okay,
And then the other one is grams per mole.
Yeah.
5, okay, is really, I would say it's simple because it's like either step 2 or step 4 in those 4-step problems. Or, excuse me, 5-step problems. Because I'm going to, after we've clarified number 5, I think that's enough for today because we have discussed everything else on that paper, enough to fill in the gaps. Okay? So, what is it about number 4? Is it a known or an unknown substance?
4 or 5.
Did I say 4?
Yeah.
Oh, my mistake, your fault. Okay. So, in number 5, is it a known or an unknown substance? It is a known substance. And what is it asking for?
Heat energy, so joules.
Joules or kilojoules. So, what you're going to want to do, okay,
Here, I wrote it down if you want.
do we need to do any converting here? Why are you right?
It's in grams and it's in joule over grams.
Yeah, so once you cancel out your grams, you're in joules, and that's what you want. That is correct. Okay, so number 5, does anyone not, darn it, I did it again. I'm thinking of the steps and not the problem. Okay? In number 8, does anyone not have the specific heat of ice, water, and steam? Okay, otherwise it's 2.02. No. 2.06, 4.184, and 2.02. Water's molar heat of fusion is how many joules per gram? 334. And then the molar heat of fusion for steam is 2,260. So it's 5 steps. Every time you get it into joules, you add those 5 steps together, and that is your answer. And we talked about number 10 yesterday. Okay, so the rest of the time is yours. The paper that you get tomorrow, okay, I'm going to pick on the women or the ladies in here, shouldn't we? Can we?
Yes, we can.
We can.
It's all about equality.
Okay? So,
Cloud.
who do we Okay, so as far as the ladies go, who do we pick on? Should we just look right? You just looked right. Just look over there.
Pick one. It doesn't matter.
Yeah. You're the ranking member for the ladies in here. Doesn't that make you feel better? You outrank everybody in here. Are you older than them two?
I think so.
She's
See,
definitely older
then you're definitely
she's
the
definitely older
ranking
than me,
member.
and he's not 18 yet, so are you 18?
Yeah.
Yeah, so.
Okay? So, any one of the guys in here, or later down the road,
Yeah.
your 2 favorite words that a guy or your guy's going to tell you. You know the answer already. See, just look around at the guys, your 2 favorite words. Trust me. See, now doesn't it make you feel better?
Hey, you'll get out a lot going through life. Trust me.
Okay. So regardless, it's going to be better tomorrow. Trust me. All right, we'll catch up to you next time.